We're going to, like I said, learn a bunch of new words today, which will allow us to talk about the logic involved in geometry, especially as we get closer to working with proofs. We want to understand a whole bunch of different words that will allow us to converse with respect to proofs. So, first things first, we need to recognize some patterns. So, part of the puzzle that we're building here in geometry requires being able to recognize patterns, and that's in essence what a proof is. Some of the things we've already done, we start looking at a scenario, we notice that the same thing happens over and over again, and then we make a general statement. Okay? In order to do that, you have to be able to recognize those things happening. So, first question: what are the next two numbers in this sequence? Paul?
It'd be 21 and then 34, right?
Good. Why?
Because each time you're adding the number, you're adding the last number and the number that came before it to get the next one.
That makes sense?
Yeah.
1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, etc., etc. Do you know what that's called, Paul?
Fibonacci.
It is the Fibonacci sequence. Okay, let's try a different one. What are the next two letters in the sequence? Anybody? While you're thinking about that, notice the dots at the end of these, meaning the sequence continues on for quite some time. We'll see one eventually where it doesn't have a dot, and we'll talk about that when it comes along. No clue? Going once, going twice. Those are the answers. Why? You're not going to be happy when I tell you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, how about that one? You might want your calculators, by the way. Michael.
Went 1, 6, 6, and 6, and 21, 4, 2. Oh, whoops.
Where did yours come from?
Oh, I did the wrong thing. I didn't
Put your
do
hand
one.
up.
I didn't.
Where did my answers come from?
Yeah.
No. Cool.
They came from the fractions 5, 6, and 6, 7.
But why 5, 6, and 6 sevens? What's the pattern?
Because they're like fractions, so like 0.5 is 1/2, and 0.667 equals 2/3.
So this is 1/2,
Yeah,
or 1 over 2,
yeah,
2 over 3,
yeah. 3 over 4.
3 over 4.
4 over 5.
Yeah, what about that guy right there at the beginning, though? What's that?
It's just like 0 over 1, I guess.
Good. 0 over 1, 1 over 2, 2 over 3, 3 over 4, 4 over 5, all the way out here. So it's fractions increasing the numerator and denominator by 1 every time. How about these guys? Next letters in the sequence. Ashley, what do you think? Gesundheit. You can guess, it's okay. Nothing? Alright, I'll tell you the answer then, you tell me the rule. Why N and T? Maria, you okay?
I don't know if it's right.
Go ahead.
It's like the next 4 letters, the next 3 letters, next 2 letters.
It's not a bad guess, you took the mathematical approach to it. So A would be 4, then, but EF is only 1, isn't it? A, B, C, D, E,
Oh.
F.
Yeah.
So 4, then 1, then E, F, G, 2. So you think there might be a numerical sequence in there?
Yeah.
Yeah, it's not that difficult. How about just the letters with no curves?
What?
Sorry. God. Alright, how about that one? I know what you're doing. You're doing plus 2, plus 2, plus 1, plus 1, plus 2, plus 2, plus 1, right?
Yeah.
Yeah, that's not right. There's the answers. It kind of does follow that pattern though.
Yeah.
Plus 2, plus 2, plus 1, plus 1, plus 2, plus 2, plus 1. But that's not the reason why it's 16 and 18. Emmett?
All numbers that are prime.
Good. You know what those are called, by the way?
Composite.
Nice. Composite numbers. Well done. If you didn't like the letters with no curves, you're really not going to like this one. And by the way, the answers are not 200 and 500. I'll tell you the answers. You can tell me where those come from. Why is it 500 and 1,000? You're never going to get this.
Thanks.
No problem. Ben, any ideas? No? It's US dollar denominations. $1 bill, $2 bill, 5, 10, 20, 500, 1,000. I think there's a $10,000 bill also.
Really?
Yeah. Okay, last one. Notice the difference between the last one and the others. There's no dot, dot, dot after it. This is what's called a finite sequence. It stops after that list of numbers. So the question is, why are those numbers in that order? Let's see, -3, -1, +5, -8, +6. No. See, we got a curve and a curve, but then a straight line, then a curve, but a straight line and a straight, no, that doesn't work. Will, any ideas? Morgan? Anybody? Disappointing. Those are the numbers 1 through 10 in alphabetical order.
Are you kidding? Oh my gosh.
8 begins with an E, 5 begins with an F, 4 begins with an F, F-O, F-I, F-O. So, some of these require you to think outside the box a little bit. Okay, first new word today, conjecture. Conjecture is an educated guess. Not a guess, but an educated guess. Brenna, how old am I? It's not up on the board.
Huh?
Don't get her in trouble, Beth.
40?
40. You just got an A in the class. Brenna, is that an educated guess or is that a guess?
That's an educated guess.
Why?
Because I'm making like an assumption from what I don't know.
I'm standing here, you know how I look, you know certain things
Yeah.
about me, so it's that an educated guess.
Yeah.
Good. Hey, Brenna, how old is Stan Isowitz?
Huh?
Stan Isowitz, how old is he?
I don't know who that is. um, 20?
Guess or conjecture
Guess.
about Stan?
Well, I would say it's a guess because I don't know.
You know absolutely nothing about him, okay? So there needs to be a distinction between just making a blind guess and making a conjecture. Her guessing my age is a conjecture because she has a certain amount of information that she can use to determine. She has no idea who Stan is, so she's just making a blind guess. What we're going to use as we do these proofs is something called inductive reasoning. There's two types of reasoning. There's deductive and inductive. We're going to use inductive. Inductive goes from very specific examples and makes a generalization. I open up the window, I hold a tennis ball in my hand, I open up my hand, the tennis ball falls. I open up the window, I hold a chair in my hand, I open up my hand, the chair falls. Those are very specific examples, but then I can make a generalization that if I hold anything in my hand and I open up my hand, it's probably gonna fall. Unless, maybe it's sticky, good. Maybe it's a wad of peanut butter.
Or we're in outer space.
Or we're in outer space. Or it's a balloon filled with helium. Okay. That's the basis of the reasoning we're going to use. We're going to look at specific examples and then make a general statement. Okay, so I have these two parallel lines cut by a transversal. It appears that these two angles, which we call alternate interior angles, are equal. You measure them, yep, they're equal. You do it again. Two parallel lines cut by a transversal, measure the alternate interior angles, they're equal. Then you start to make a generalization. Okay, let's do some more pattern recognition since you guys are so good at it. Billy is preparing toast for breakfast. After a few minutes, the bread popped up but was not toasted. What conjecture can you make as to why the bread is not toasted, Jack?
The toaster was broken.
Excellent, the toaster is broken. Any other ideas? Wasn't on a high enough power. It was on the lowest setting, and when it popped up, it had toasted, but not enough to appear to be toast.
It wasn't plugged in.
Wasn't plugged in, very good. Anything else? My toaster actually won't click down if it's not plugged in.
Yeah, same.
Yeah. I don't know why, but. Any other reasons? Excellent. Megan? What does P-O-S-T spell? Good. What does M-O-S-T spell? Good. What do you put into a toaster?
Toast.
No, you put bread in it. Now it's toast. I got you. Okay. Draw the next picture in the sequence. Excellent. Everybody's got it right so far. Good, 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 good. Good, good. Hey, Grace, quick question for you. What color would it be?
Green,
Why?
because that's the rainbow.
Very nice. Roy G. Biv, red, orange, yellow, green. Well done. Okay, counterexample. So, there's a lot of different examples that we can come up with. Some of the things that we are going to make statements about are going to be false, and in order for something to be false, you have to have a counterexample. In other words, something that proves it false. We had one already when I was talking about dropping things out the window. Michael said it could be something sticky, like what do we say, a wad of peanut butter. That would be a counterexample. It's something that proves something false. Here's the weird thing about logic. If I want to prove something true, I have to prove that it's true for all possible scenarios. In order to prove something false, I only need one counterexample. So a lot of times it's a lot easier to prove something false than it is to prove something true. All dogs have 4 legs, true or false? False. Why? Could be a 3-legged dog, I've seen one, they're pretty sad. But there is a 3-legged dog out there somewhere. In order to prove it true, I'd have to find every dog in the world, count their legs, and they'd all have to have 4. Once I find that one 3-legged dog, done. It becomes false. Now notice the way I phrase this. Both of the following statements are false. You don't have to determine if it's true or false. I'm just telling you, it's false. What makes it false? In other words, what are the counterexamples? You got both of them?
I have one.
You got it.
Or actually.
You got them both.
You're sure.
Okay, go. Which one do you want to do first? 1 or 2?
One.
1.
Actually, I just have the first one.
You just have the first one.
Yeah.
Okay, go.
0.
0 is a counterexample for number 1. Well done, because 0 is not greater than 0. Any other counterexamples for number 1? Becca?
Well, I have one for number 2.
Okay, hold on. Let's finish with 1 and then we'll come back to you. Emily, what do you got? 1. 1 squared is not bigger than 1. Any other counterexamples? Go.
If x was a fraction,
Can you be more specific?
like 1/2.
Could you be more specific? What's true about those fractions?
When you square.
Because I mean, 100 over 7 is a fraction. Right? So what fractions are you looking for?
Regular fraction,
Such that,
the numerator is less than or equal to
good, that'll work, yeah. In other words, a fraction between 0 and 1. All right, Rebecca, what do you got for 2?
Platypi.
Platypi, went plural on us, huh? If you have one of them, you have a platypus.
Yeah.
If you have more than one, you have platypi.
Yeah.
Radius, radii. Jesus, Jesus. School bus, school by. Excellent. There's a picture of one. They are mammals. They're ugly. Something else not a lot of people know about the platypus, maybe you know this, they're venomous. You know that? You can die from a platypus bite. So think twice before you pet a platypus.
Yeah, go ahead.
Yeah, they have teeth inside the bill.
Well, what about Perry the Platypus?
Have you ever seen Perry bite anybody on the show?
Yeah.
If you did, that person was probably not on the show anymore. Okay, let's watch a quick movie, shall we?
I would.
Hopefully this will work.
Oh god.
It's like a security.
What?
It is a security video. Why is it working? Oh, wait a second. I think I may have to click on the screen. Hold on. Watch carefully now.
I'll try my best. Oh my god.
Ouch. Okay, if-then statements. So most of the things that we do, we call theorems, and those theorems should be written in if-then form. They're also known as conditionals. You can use either term. Most people just call them if-then statements. You can also call them conditionals. The reason I shy away from the conditionals thing is you'll see we're going to get a lot of words today that begin with the prefix con, and so I don't want conditionals is just going to further complicate things. So I usually call it an if-then statement. I also call it an if-then statement because it's got an if and a then in it. If today is Monday, then yesterday was the weekend. It's a conditional because the second half of the statement is conditional on the first half. If yesterday was a weekend, it's gotta be Monday. That first part, the if then, or the if statement is called the hypotenuse, hypothesis. I'm an idiot. And the second part is called the conclusion. You gotta have a hypothesis in order to have a conclusion. By the way, Michelle, is that a true statement?
If there's not a limit, yeah.
Good. How do you know?
Um,
Is there any counterexamples?
no.
No. Let's move on. We'll talk a little bit more about true and false as we work our way through. Being mathematicians, we're lazy, so we abbreviate everything. So this is how we're going to drastically abbreviate some of the logic stuff we do. We assign the letters P and Q, P for the hypothesis, Q for the conclusion, and then we introduce that little arrow thing. We've used the arrow already, it means implies. So we can take a conditional and phrase it as P implies Q. P will change, Q will change, but that still gets the idea across of the conditional. And we're going to run into some issues because not everything will be given in if-then form. Sometimes we may have to convert some things. Are we okay? Am I going too fast? We're good? Okay. So, for instance, we could take that last example and just write it as Monday implies yesterday weekend. Which you sound kind of silly when you read that out loud, but for us, again, we're lazy and we want to shorten things as much as possible. Okay, so let's suppose we're given something that's not an if-then form. Like, for instance, the statement that says, all cows moo. That's not an if-then form. We want it to be an if-then form. And so you have to ask yourself a simple question. What came first, the cow or the moo? The cow came first. So what would that be in if-then form? And let's try to write it in regular English, not weird gibberish. Madeline,
If there's a cow, then it moves.
well done. If there is a cow, if something is a cow, if an animal is a cow, however you want to phrase that, if there's a cow there, then it moves. Or if you prefer, cow implies moo. But again, that sounds really ridiculous. But a lot fewer words to write. So let's talk a little bit about cows mooing. Is that a true statement? Do all cows moo? So you might say to yourself, that's not a true statement because there are probably some cows out there that don't moo. When we start talking about logic, we're going to make some assumptions. We're going to make assumptions as a generality, if that's even a word. Meaning, for the most part, dogs have 4 legs. For the most part, cows moo. Yes, there's probably some cow in Nebraska that laid its neck on the electric fence and burned out its vocal cords, so now it just goes moo instead of moo. Okay, but for the most part, that is a true statement, right?
Sure.
Okay, again, we're going to ignore the what we call the outliers, the weird, the dog that's missing a leg because it, I don't know, was involved in a gang war or something, or the cow that's is just getting in touch with itself and refuses to speak. There's exceptions to everything, but for the most part, that is a true statement. Okay? So we take the P implies Q and we can switch it around and get what's called the converse. The converse is when the hypothesis becomes the conclusion and the conclusion becomes the hypothesis. So P implies Q becomes Q implies P. So for instance, from our first example, it would be if yesterday was the weekend, then today is Monday. Molly, is that a true statement?
No.
Okay, you got all bases covered now, this one.
Yes.
Are you confirming that you have all bases covered, or that you think it's a true
I'm
statement?
saying that I think it's a true statement.
It's actually a false statement.
You didn't know what date it is, Molly.
True, Saturday or Sunday.
Saturday.
If it was Saturday or Sunday, you don't know which day it is.
There you go. So our counterexample then, that's a false statement, because if today is Sunday, yesterday was the weekend, but it's not Monday. Okay, so that's our counterexample. So it is a false statement. There is no relationship between the trueness of the original statement and the trueness of the converse. They're not related in any way, shape, or form. And so logically, there are three possibilities. Stay with me on this one. They're both true, they're both false. One is true, the other is false. If something moves, then it is a cow. Is that a true statement, Will?
Yeah.
It is?
Moo.
Do it. That's your best moves.
What do you want from me?
That's a move.
We're surrounded by cows.
I'm not really good at
There's 30 counterexamples for you, Will. Okay? Just because something moves doesn't, I can't even speak. Just because something moves doesn't make it a cow. But if it's a cow, it's gonna move.
Yeah.
Inverse. We're gonna negate the statement. So some new terminology there. See that little tilde? That's called a tilde. The tilde is a negation of a statement. So if I say something like, I like dogs, the negation of that statement would be, I don't like dogs, right? Are we with me on the negation thing? Okay, it's the opposite. I don't like cats. What's the negation of that?
I like cats.
I like cats, right. So the inverse then keeps it in the same order but negates both of them. If something is not a cow, then it does not move. By the way, Ben?
Yep.
What's that a picture of?
It's a picture of a cow.
Nope,
Oxen.
nope, nope.
Cattle? It's a cartoon.
I'll give you a hint.
Sure.
Cow with no legs.
Ground beef.
It's ground beef! Get Ben?
It's not.
Cow with no leg, ground beef. Okay, good. The scene who's paying attention.
Cows don't have
It's a very sad
horns.
looking cow.
You're right, it's a bull, sorry.
So it's bull beef.
It's a bovine with no legs.
Is that why it's so sad?
Probably.
It looks like it's about to start sobbing.
True.
Look at its eyes.
What do you think, those are tears around its
Yeah.
eyes?
Yeah.
That kinda looks like.
It doesn't look very happy.
Well, if you were a bull with no legs, you'd be sad. You would be the joke. You know what you call a dog with no legs?
A dog beef.
No, you don't. It won't come when you call it anyways. No, not so good. All right, let's try this one.
Mystery.
What do you do with a dog with no legs?
Don't call it.
Take it for a drag.
That's awful.
All right, I got one more. What do you call a dog with no legs and steel testicles? Sparky. We good? Everybody got that? Nobody needs an explanation?
No.
Okay, good. Let's move on.
Wow.
Contrapositive. this one gets a little weird. We're gonna do both the converse and the inverse to our original statement. So we're gonna switch the order and negate them. Switch the order and negate. So it's the converse and inverse, or the inverse and converse. If something does not move, then it is not a cow. The inverse and the contrapositive are frequently difficult to figure out whether they're true or false. So I've got some stuff that'll help you in a little bit. We can actually avoid figuring out whether it's true or false, because I have a couple theorems for you. Okay, so those are our four main logic statements: the original conditional, the converse, the inverse, and the contrapositive. And I told you there are a lot of words that begin with CON, so if you want to call it the if-then statement, the converse, the inverse, and the contrapositive. Okay, so let's start with this. If you live in Mount Prospect, then you live in Illinois.
Yes.
Wait, we're not talking true or false, we're just getting this under control. What's the converse, Megan?
If you live in Illinois, then you live in Prospect.
Perfect. What's the inverse? Dev?
If you do not live in Mount Prospect, then you do not live in Illinois.
Perfect. And what's the contrapositive, Michael?
If you don't live in Illinois, you don't live in Mount Prospect.
Good. Excellent. Got that under control. Let's talk about the original statement. Is the original statement true?
Yes.
Yes. Now, there's a Mount Prospect in Guadalajara. Yeah. Yeah, shut up. It's a true statement. Who gave me the converse? Megan, was that you? Well, give us the converse again.
If you live in Illinois, then you live in Mount Prospect.
Is that a true or false statement?
No.
False, because you could live in
Arlington Heights.
Arlington Heights, Schaumburg, Peoria.
Chicago.
Thank you. Deb, you gave us the inverse?
Yeah.
What was it?
If you do not live in Mount Prospect, then you do not live in Illinois.
If you do not live in Mount Prospect, then you do not live in Illinois. True or false? False. Counterexample? Arlington Heights. You don't live in Mount Prospect, but you're still in Illinois. And then the contrapositive was, Michael,
If you do not live in Illinois, you don't live in Mount Prospect.
true or false?
That is true.
That is also true. And you can see trying to figure out the inverse and converse can get a little confusing. So let's talk about this whole scenario. Initially, it would seem that there's only two possibilities, true and false, but there's actually three. CBD stands for cannot be determined. This complicates things a little bit. So what makes a statement true? In order for a statement to be true, the hypothesis has to be true or possible, that's another way to look at it, and the conclusion must be true. Okay, so if something is a cow, can you find a cow somewhere?
Yeah.
Yes. Can you check whether or not it moves?
Yeah.
Will it move?
Yeah.
Yes, so that's a true statement. What makes a statement false? The hypothesis still has to be true, that's an important idea. But the conclusion is false. Can you find something that swims? Yeah. Does it have to be a fish? No, it could be. It could be what? Oh, Michael Phelps. I thought he said bicycle wheels. Now here's the weird one. What if the hypothesis is not true? We can't determine whether or not the follow-up is true or false. Is the moon made of green cheese or made of cheese?
No.
No, so we don't know whether or not I eat glass. I might, but then I might not. So it becomes a statement that is neither true nor false, because in order for it to be true or false, we need to have the moon made of cheese, which it is not. So you'll never know.
Do you eat glass?
It's not relevant right now. It cannot be determined. Can't you read?
If we ask you.
Yes. If you ask it in a different way.
Excuse me, I wasn't done.
Done what?
I wasn't done writing. Thanks.
Are you writing that I eat class?
That's true. Yeah, come
You.
on. Wait, what? Glass?
Huh? What? I'm talking about.
It would be the cute eyes.
What's that?
Imagine how painful that would be. You have
I've
those
had worse.
sticking out.
I've had one at once. Oh, there's a piece of mirror. Okay, here's your useful theorems. Instead of trying to figure out whether the inverse or the converse are, sorry, inverse or contrapositive are true, we can use these guys. There is a direct relationship between the conditional and the contrapositive, okay, which gives you those two. If the conditional is true, the contrapositive is true. If the conditional is false, the contrapositive is false. Those are directly related. So instead of trying to figure out the trueness or falseness of the contrapositive, go back to the original conditional, because those are usually a lot easier to work with. The same relationship exists between the converse and the inverse. They're either both true or both false. So when we get to something bizarre like, if you don't live in Illinois, then you don't live in Mount Prospect, don't worry about it. Just recognize that that's the contrapositive. If the original conditional is true, then the contrapositive is true. Okay, we good?
No.
How about now?
Nope.
No.
How about now?
No.
Now?
No.
And now. Good. Let's try it out now. What is that?
A bat.
Very good. If an animal is a bat, then it can fly. Kaylin, true or false?
False.
Why?
Because more animals than just bats can fly.
Well, what's our hypothesis? What do we have to start with?
If an animal is a bat,
So we're starting with a bat. Will that bat fly?
yes.
Yes. So true or false?
True.
True. Okay, it's true. No counterexample. Again, there's probably a bat that lost its wing in a bug zapper or something and just flies in circles or just flops around. But that is a true statement in general. What's the converse? Morgan.
If something can fly, then it's a bat.
If something can fly, then it's a bat. Is that a true or false statement, Morgan?
False.
It's false. So if it's false, you should have a counterexample for me, right?
Yeah.
Okay, so what's something that can fly that's not a bat?
A bird.
A bird. Okay, so this was true. This was false. Bird. Or airplane. Or mosquito. Or
Airplanes are spiders.
spider. Flying spider? What's wrong with you people? Squirrel. Squirrels don't actually fly, they glide.
Airplanes aren't even animals, and you said
They
airplanes.
don't actually take off.
They
and-
drag.
Yeah, they have no legs and they drag. That was good, I like that. What's, I'm totally stealing that. What's the inverse? Emily?
It is false.
No, what is it first?
If an animal is not a bat, then it cannot fly.
Perfect. If an animal is not a bat, then it cannot fly. Again, I'm not gonna, well, okay, what, true or false?
False.
Why?
Because some animals that aren't bats can fly.
Thinking too much. Why is it false?
Because the converse is false.
Good, because the converse is false. So once you get these first two, don't overthink the last two. Relate them back to this. So before I even put it up there, is the contrapositive going to be true or false?
True.
It's true. What is the contrapositive? If something cannot fly, who's talking? If something cannot fly, then it is not a bat. True or false? And we already established that it's got to be true. So again, you see that relationship there. The original statement and the contrapositive have to be the same. And the converse and the inverse have to be the same.
Always?
Always, no exceptions. Okay. So again, you don't have to beat yourself up trying to figure out, well, the knots, you know, if it's not a bat, well, could it be this, could it be that? Question?
What was the first part called? The first, like, just like,
This?
yeah.
Conditional, or the if-then statement, whichever one you prefer. Okay, we good? Lot of terminology in this lesson. So part of it is going to be practicing so that you remember what each of those 4 statements are. Fast fact for today, a baby bat is called a pup. Until it bites you and gives you rabies.